All right, guys, so here's where we seem to struggle a little bit. We're going to presume that I went ahead and completed the rest of the screens up until screen 7. The instructions say to use the e-tool that is linked below or sketch in your math notebook the rectangle for the following equation. So we'll do both. First, I want to use the e-tool because I want you guys to know exactly how to use this. I'm going to click on the link and it's blank. My expression here says that we have 6x plus 15. And then it looks like I need to fill in my table for the length and the width of the rectangle that I create, because using the e-tool linked below, or in our notebook, we need to sketch out the rectangle for the following equation. But we need the length and the width, and then the area of the rectangle as a product of the length and the width. So I'm going to go to my tiles, and I know that I need 1, 2, 3, 4, 5, 6 of the X tiles. I'm going to make them a little bit bigger for you. So I have 6 X tiles. And then I know that I need how many ones? 15. Now, I need to make a rectangle. So I've got all these rectangles and all these squares. I know that I've got 6x plus 15, but how am I going to go about doing that? Well, I'm going to go ahead and start by just bringing all of my x's over here and starting to make a rectangle out of those. So I can stack them all across, can't I? But when I do this, I know I've got 15 ones. So if I've got 1, 2, 3, 4, 5, 6 x's across, I know that I can get one row of 6 of my unit tiles or my 1 tiles. But when I go to put my second row, I'm going to find out that I have a few left over and that I can't create a full third row of tiles, resulting in me not having a completed rectangle for my image. So if I take a look at what I have now right here and I bring it right in the center, this is not a rectangle. We've got 1, 2, 3, 4, 5, 6 sides. So that's not a rectangle. So what do I got to do? Well, we got to play around. We know that I can't do this because there's no way that my X tiles will perfectly be X. So what I need to do is figure out another way for me to stack them. But Mr. Hill, they're still not a rectangle. But if I try and take some more of my tiles and I click and drag them around, you can see that now I have a stack of tiles. So I've got this nice big stack of tiles right here. And I've created it. So now I want to know, what is the length? Again, you can pick what you want your length to be, but I'm going to call my length this vertical distance that's right here. So what is my length overall? I've got x plus 1, 2, 3, 4, 5. So I've got a length of 2x plus 5. And what's my width? Well, if I take a look right here, my width of tiles is going to be 1, 2, 3. And why is it 3? Because remember, if we take a look at our cheat sheet for the dimensions of algebra tiles, my X tiles have a long side of X. The short side only has a width of 1, which is the same distance as our unit cubes. So here in the algebra tiles, you can see that I've got a width of 1. And so since there's 3 X tiles down here, my width is just 3. Not 3x, just 3. The length here has 2x tiles, which is why it'd be 2x, but the width is just 3. So then if I write my answer for the area of a rectangle as a product of the length and the width, then I'm going to have 3 times 2x plus 5. So if we take a look at our final answer here, you have your length and you have your width. And the product of my length and width is just oddly enough, the length times the width. And we got that again from our dimensions of our algebra tiles. Alrighty guys, so here's a review of what you may have thought was the toughest screen yesterday, and this is the style and the format of the way that these next couple of questions are going to go. You had this image. You had a rectangle that was already made. So previously you've made rectangles. This time you've got a rectangle that's already created. And you have the tiles labeled, actually. So you've got x squared, x, 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 and a whole bunch of unit tiles already up there. And what we need to do first is we need to find the length and the width. So step one is we're going to find the length and the width. So for the definition of these problems, my length is going to be the vertical side and my width is going to be right here. Because when I think like long and tall, I'm long as tall, I'm tall, and width is how wide I am. So for these algebra tiles, what we're going to have is we're going to have our length, we're going to have our width. So if I take a look at my length, I need to think about the side lengths. My x squared algebra tile has a side length of x. And then my x tile, the length of x is right here, but it's 1 and 1 right here. So my length is x plus 2. So my length is x plus 2. And I'm going to write that in black, just so that way it's easier for you guys to see over here. Now, when it comes to the width, I need to take a look at this lower side. So I've got an x squared tile, and I already know that this side length right here has got to be an x, because x times x is x squared. This also has to have a length of x. This x tile that has an area of x, its dimensions are x times 1, so since it's got a height or a length of x, but a width of 1, I know that this is a 1, this is a 1, this is a 1, and this is a 1. So I've got x, I've got 2x, so 2x plus 1, 2, 3, 4. So my width is 2x plus 4. So I'm going to switch to my black marker again and answer it. So since I am given this image for the algebra tiles, my length is this vertical distance, and my width is the horizontal distance. And I'm going based off of the dimensions of the algebra tiles, which I know from the algebra tiles cheat sheet that you guys have access to while you finish completing this quiz. So now that we have our length and our width, what we need to do is we need to find our area as a product. So when I ask for your area as a product, I'm not asking you to actually multiply things. I'm asking you to show me the multiplication that's implied. So taking a look at that now, I know that my length is x plus 2, and I know that my width is 2x plus 4. So as a product of my length and my width, because the area of a rectangle is length times width, I know that the area is just going to be x plus 2 times 2x plus 4. So this would be my area written as a product. This would be the answer that I'm looking for right here in parentheses. There's no need for you to multiply it out. But then for my area as a sum, so we know that our algebra tiles are named after their area, right? My x squared tiles have an area of x squared. My x tiles have an area of x. And my 1 tiles have an area of 1. So what I got to do is I need to add them all up. So I've got 1x squared, 2x squared. So I've got 2x squared plus, because again, it's a sum, so plus 1x, 2x, 3x, 4x, 5x, 6x, 7x, 8x. So I've got 2x squared plus 8x so far. Plus I have yet to count all of my unit tiles, and I've got 1, 2, 3, 4, 5, 6, 7, 8. So my area as a product is x plus 2 times 2x plus 4. And my area as a sum is 2x squared plus 8x plus 8. So when I ask you to find the length, find the vertical side length. When I ask you for the width, find the horizontal side length. Your area as a product is simply the expression for your length times the expression for your width. And your area as a sum is just counting up and adding together the values of all of your tiles. And again, I don't want to trick you with the algebra tiles. They are named after their area. So the x squared tile has an area of x squared. So you're really just counting the tiles. So when I ask you for the area as a sum, you're just counting. I've got 2x squareds. All right, I've got 8 x's and I've got 8 1s. So for these next couple of questions that I ask you, revolving around being given these rectangles, find your length, find your width, give me the area as a product, and give me your area as a sum. And then at the end of the problem, you're going to upload the picture of your work where you have sketched this out on your notebook, labeled the length, labeled the width, and then given me these areas in the form of a product and in the form of a sum.